Okay, we are live. Hey guys, welcome back to another live stream. Thank you so much for tuning in if you are following along the journey. And as you can see over here, in our last live stream, we had to cut the stream early because of some battery issues with our camera, but we did proceed and put together this actuator. Sorry, the arm of the robot. So this one has one M6012 actuator and a bunch of other 5010 actuators, and this thing is, it looks pretty neat, to be honest. With all the efforts and all the sprints we've done in the live streams, this thing looks really clean, and it as you can see, it moves in all these various directions. It has so many degrees of freedom, and you can twist it and turn it in any position you want to. So what we're gonna be doing today is we are gonna put together the other arm of the robot live in this live stream, but we do have one step to do before that. I am gonna place this carefully to a side, and we are gonna assemble the other arm.
I'll just keep it like this in the live stream. And once again, good morning, good evening, or good night, depending upon where you're watching this from. It's a chilly night out here in Tokyo, and it's raining outside. It's quite cold. I've already had my fair share of cold during this season. But yeah, we are continuing with the development of the humanoid robot. We have assembled one arm so far, as you can see. I must admit, it looks really beautiful once it's assembled. Really beautiful in real life. The camera really does not do it enough justice. But yeah, we are continuing with assembling the other arm, and after that, hopefully we will use the aluminum profile, create sort of a base or chest area for the robot, and then attach both of the arms, and we'll be able to show hopefully by the end of this live stream. We have all the components ready. All of the actuators are calibrated. There's just one actuator which we need to calibrate, but other than that, everything should be pretty good to go. Hopefully we have all of the components. As always, we are really not sure about the components because parts pop up which are not mentioned in the BOM, and we have to search throughout our lab to find some parts which can make work. But yeah, let's continue with the development.
Yeah, at least in our case, we used a lot of replacements, a lot of parts that went into this arm of the robot. They are non-standard, or at least they are not the ones they recommend to use in their documentation or bill of materials. So we had to wiggle around a lot with the design, but if you have enough time, if you can source all those components, and I would recommend taking your time with everything, because sprinting this thing is not a good idea.
Yeah, by the way, if you can take one screenshot from here, because this image looks really good. Yeah, this one is good. Awesome. So yeah, we have this one motor driver which we need to calibrate, one upper arm YL. If you have watched the documentation, they have mentioned the exact CAN bus ID to use with these actuators. I have already noted it down in a notebook over here. If I can showcase over here, so I have noted all of these down. I have put a tick in front of all of the ones which we successfully calibrated for the right arm, the left arm. There's only this one remaining which has a CAN ID of 3. This is the most important part, the CAN ID of 3. Now I'm gonna be replicating all of these details inside of the software, and we're gonna start calibrating this actuator. right after that we will start assembling the other arm. So yeah, let's get started. For now I am just making basic adjustments to the software. So in the motor controller configuration, first of all we want to make sure we have the right device CAN ID, which is 3 in our case. Alright, that is set. With that, we're gonna move the first time boot up flag to 1 because this is the first time making connection with this actuator.
We do need the USB CAN adapter over here, so you might want to attach this while you're at it.
Okay.
And there, the screwdriver for that is gonna be there in that red box inside the drawer.
Yeah.
It's so awesome to finally see the robot coming together, and I really hope we can also proceed with at least a little bit of software side as well. Once we have assembled the robot, we would like to try to move it a bit.
Yeah, I mean we've had many live streams. This is our 11th live stream this time.
Yeah.
We've had quite a run on this project, and we've been mentioning for a long time, primarily just because of the bill of materials and parts. So part sourcing took us a long time. The PC that we have over here for this humanoid just arrived literally about 2 or 3 days ago. Just 2 to 3 days ago. So that took us a lot of time. But it's so good to finally start assembling the robot. And honestly, it's all worth the effort. It's all worth the effort. It looks really good in real life once the arm is assembled.
I don't think we need to attach this one. Yeah, so it's this one. So I also need, once you calibrate this, I'll attach this using a double-sided tape. So we need to calibrate it first.
Here.
I'm gonna put the battery on charging once we have calibrated this motor. After that,
yeah, so last time for this actuator we actually had to sprint quite a bit. For the viewers who watched the last live stream, we were actually not able to go through all of the live stream just because of the charging issue, but we had to rush through this assembly, and because of that the soldering connections and wires are not that perfect. But for this arm, we would prefer going through a relatively standard procedure whereby all of the wiring connections and cables are very perfectly placed or taped out if possible, so that way all of them are very smoothly flowing through their unique channels. That way we'll have some ease in connecting all of the wiring later on, because we also need to do that for the assembly. So yeah, we would prefer to use a very standard route for wiring for this arm today. I've actually forgotten, the yellow one goes in the middle.
Yeah, it goes in the middle. So our last live stream is roughly 5 hours long, 5 hours 15 minutes around that time. And after ending that live stream, we did work on this robot for roughly 4.5 more hours. So it was quite a long sprint, and this is what came out of that sprint. And we had to wiggle around with the design a bit because as we mentioned, a lot of materials were not available to us, or a lot of materials were not mentioned on the documentation for this robot, especially these screws that you are seeing over here. These are M3X20 screws over here, and they were not mentioned on the bill of materials at all. And we also needed M3 nuts for the assembling this arm, and thankfully we had these materials available in our lab. Otherwise it would have been like another 24 hours or 48 hours before we got those materials. So we only have one more motor calibration to do, which we are gonna do right now, and immediately after that we will be starting the assembly of the other arm of the robot. And once that's done, it's not gonna take that long because we already have experience putting one arm together. It's gonna be real quick. But after that, we once we're done with the second arm, we're gonna put both arms together on an aluminum frame, so it kind of looks loosely looks like an upper body. And then we are gonna record the video, and we're gonna show it on the live stream how it looks.
Alright, first time boot up is set to 1. We have the correct device CAN ID as well. We're gonna run the very first flash for this motor. Yes, update. I think the reason why they ask for update every time is because the update is specific to the driver. So whenever we bring a new driver in, it needs that firmware update.
The motor controller. Okay.
Yeah, the motor controller.
Yeah. Gotcha. That makes sense. Yeah.
Alright, let's run this once again, and hopefully it works this time. Alright.
Yep. It ended up working. So we had one motor driver that was failing for some reason, but we just changed the motor driver before starting this live stream, and this motor driver is working now. Hopefully the calibration for this motor is successful, and then we're gonna move on to assembling the arm of the robot. I'm really looking forward to it.
Okay, we're gonna connect this motor driver once again over here, and just run the code for the second time. Fingers crossed. Yep, this one was also successful. Awesome. I don't know if you guys can see, but there's a very subtle
you need
flashlight.
to put it a little bit
Okay, over here, and if I can bring it up a little bit, I don't want to pull in too much of the wires.
Okay, now you can do this.
Yeah, but there is a very subtle red RGB light which
Yeah,
is
it's
blinking
visible
at,
now in the video.
yeah, it's blinking at 1 hertz.
Okay, now let's put this back down.
Okay, I'm gonna remove this once again, make the changes once again over here. Load ID. Yes, this time we also want to load the CAN ID. 1 1. All right, these connections. Okay, this is also done, as well as this. And yeah, let's push this code. Awesome. So this is ready to start calibration and testing. So this time we need to make the battery connections. First of all, I'm going to remove this, as well as remove this from here. And yeah, let's make the connections.
Okay, to power this motor we are using this Inco 20-volt battery. It's a pretty standard battery. You can find it, I think, pretty much anywhere in the world, and it comes in really handy every now and then whenever you don't have a power supply available at your lab. A lot of motors need this kind of power to power up. We've been using a lot of stepper motors in our projects as well, and we powered those using this battery as well, so it comes in really handy. It's a good investment. So I'm gonna be attaching this motor, this battery to this motor, and we are gonna see if it works or not. This is the last motor we are gonna be calibrating before moving on to assembling the arm of the robot.
Once the connections are done,
I want to double check the position of the ground and the voltage pins just to make sure they're okay. Ground is here and voltage is here. Okay.
You see, in this case, they're just lying around.
Yep.
But we wanna tape out all of them over here in a very standard format.
Yeah, I think that arm we will have to totally disassemble and reassemble because the soldering on those, especially the voltage wires on those motor controllers are really soldering in a really bad way. We will have to disassemble the entire thing and reassemble it.
Not the entire thing. I think just the joints where.
Yeah, it's alive now. You can try running it.
I'm gonna attach the can.
Yeah, like we can only disassemble the joints and solder them, having those joints or the actuators already put in there, like in their place, because we only have to play around with the motor drivers.
Yep. CD downloads, LS CD Berkeley Humanoid Light, LS CD Berkeley Humanoid Light, LS. Do we have a virtual environment here? Seems like there isn't one. Alright, let's try. Okay, it seems to be successful. I'm gonna start. First of all, I'm gonna ping the actuator. Okay.
So, guys, this actuator.
With 3. Motor is online. Okay.
The motor is online and it needs to run once anti-clockwise and then clockwise for the calibration to be successful, and it's gonna happen live right now. Let's see if it's okay. So as you can see, this motor controller is working and it's spinning the motor clockwise now, and this is what we needed. All the other motors for the arm of the robot, they are calibrated, and we calibrated them in the exact same way, and this was the last motor in the series we had to calibrate. So now I'm gonna remove power from.
Wait a minute. Let's also check the other core.
Yeah. Okay. Let's try rotating this. It's spinning really fast.
In one direction. Yes.
Yeah, it's not changing the direction. Why?
Yeah, I'm not too sure why.
I think the encoder might not be working. Otherwise, if the encoder were working, it would, of course, change its direction. No?
It could be. Can you place it down and see if it doesn't move too much? We might make a video of it over here. We also want to make sure if the magnet is attached or not.
Yeah. Yep.
Yeah. Just a second. Alright, I'm gonna stop this.
Okay, so the
do we want to make sure the
I'm gonna make sure the encoder, the magnet is attached in there, because this was some weird behavior from the motor, like it's not supposed to happen.
Open it right now. Just take off the connections.
I think the connections are okay. We can keep them on. We need the 4-headed one and the really small one too. So yeah. the motor was supposed to rotate 180-degree in clockwise and anti-clockwise direction alternatively again and again. Yeah, I think we need to be really careful with this because this screw, if it falls in there, it's really difficult to get it out of there. So let me remove this. Okay, and we need to loosen this a bit. And if you can see in there, so there is a magnet in there, so it's supposed to work, but it the magnet just moved. Oh man, so yeah, that's another issue. The hot glue gun is not powerful enough to just keep it in its place. It just moved by only applying a little bit of force.
Okay, let's attach it.
Just a second. Let me try and attach it back.
Calibrate.
I'm gonna need the tweezer for it. It's gonna be in there if you can grab it. It just a second. Okay. Okay, now if you can try and rotate it again, I am gonna grab it this way.
Okay. Alright, I'm sending the code. I think I need to connect it once again. Let me try. Yeah, a device or resource is already busy, so I think I'll just need to disconnect and reconnect it once again.
Okay.
I will do it from here.
Yeah, be careful with these power cable connections. I think we have to.
Let's see.
I don't think it will work this way, but we can try. Yeah, so we need to remove the power connections as well. So just disconnect it.
One.
And yeah, let it sit for a while.
This one as well.
No, I think that yeah, you can
While
try
we're
it.
at it. Okay, connect this again. Connect this. And finally connect this. Okay.
Yeah, so I think it was a good idea to do the second test on all the remaining motors as well.
Alright, I'm gonna push the code.
Yeah. Now it's working perfectly. So this is what it was supposed to do initially.
Yeah.
So I think it was some sort of problem with the actuator, but sorry, the encoder. And I've moved the magnet a bit, and now it seems to be working. So yeah, we can stop this now, and I'm gonna lock it in place, the encoder, this way around. Can you put a screw and just hold it while I put the screw in there. You just put one here. Okay, so done with this one as well. So yeah, I think we're good to put together the body of the other arm of the robot.
Yep. Let's remove this.
We also need to remove this connection now.
Yep.
Let's remove the power cables as well. So I'm gonna attach the motor controller on top of the actuator in this case as well.
Awesome. So we're gonna move these aside a little bit because we won't be needing the PC for a while now. We're just gonna be focusing on the hardware connections. and
Yeah,
managing
just
the wires.
yeah, just be sure to keep the tutorial up there and only have access to the mouse.
Okay, all right, yeah, that's a good idea.
And the
Yeah,
rest
by the way,
of-
the screen is really handy over here, in front of the over here, while we have one live stream screen on the side.
yeah, it is handy.
So I'll open up the building the robot. Alright. The mouse over here. And I'll just move this one a little bit to this side. These two also over there. They are not needed for now.
And
Where's the? Do you need the double-sided tape or the green one?
I've already attached this one, so yeah, this is ready.
Let's just place them one by one. Over
This
the
is
five
also
of them
ready.
here.
This is also ready. And yeah, I need to do the same for these two. Sorry, this one is also ready. So yeah, I only need to attach one more. I need to sort this one out. This is the one for the shoulder, and I only need to like sort a place for this motor controller to sit on there.
Alright, our M6012 actuator. So this one already has the aluminium profile attached to this. However, we're not sure if we placed this connection correctly. Did we reverse it? I'm not sure if we reversed it or not, but we're just gonna see from the diagram if this is the correct orientation for the arm.
I
to
think
be.
I think it's the correct orientation. I changed it, and after that we decided to only proceed with one arm. Yeah, I think we did change it. But you can open up the diagram and this you can start with it. So guys, we have all the actuators ready. Oh wow, yeah, here, no, it's okay, yeah. So we have all the actuators ready to put this thing together, and we are gonna proceed with assembling the second arm of the humanoid robot. And after that we're gonna try to put something that looks like a upper body of the humanoid robot. So if we don't have the dinosaur here, I'm gonna bring it from the outside. Yeah, I'm bringing that tool from the outside, and we need these as well to put this thing together. Quite a few of these. Yep, these.
The Berkeley Humanoid is an entirely different robot, as you can see over here. It's made of metal or aluminum. It's very robust. There are videos of people just pushing it around, and it is able to hold its own balance.
Nice.
The one that we're building is Berkeley Humanoid Light.
And it's very small. Like if you can see how long this arm is,
Yeah.
it's really tiny. I'm gonna go and grab the dinosaur tool from the outside because I don't think we have that in here.
Okay. For this arm, yep, it's over this side. think we can have the actuator like this or like this. The orientation really does not matter.
I mean, it's supposed to matter, but yeah, I mean, of course, it's gonna be this way around. So yeah, we are gonna be inserting those screws over here, right? So it's gonna, the arm is gonna open up from this side. So let's make sure this is the right arm we are making. It's a bit heavy. It's a bit heavy. It's a unit, but it's a tiny unit, but it is heavy to pick up. And yeah, this is where we attach. So this is gonna be the right arm of the robot, right?
Yeah, it's R means right.
Yeah, so this is the right arm of the, so this is, I think this is perfect to be the left arm of the robot because the orientation is the right way around. So the arm is gonna be coming up from this side, and then we are gonna start building the rest of the arm. Damn, these pesky nuts, they keep falling out.
So many wires of this robot.
Yeah, so I think we need to attach the motor on this side, no? Like,
Yeah. On this side.
okay, so yeah, let's officially start putting this thing together. The first step is to align these nuts, holes, and put
Did we put the
what?
the hex insert inside of the motor for it to fit in?
I don't know. Yeah, I don't know, to be honest. Yeah, we did not. Yeah,
So
we did not. So yeah, we need to put one in, and I have them lying around here somewhere. They are here. So yeah, we are gonna be putting this hex insert wrapped with this masking tape. It's kind of a DIY fix that we came up with, and we are gonna be putting this in there, and then I am gonna move these inside to make room for the other part of the actuator to sit in. Okay, seems ready to be put together. I'm gonna try and loosely align it. It's a bit of a struggle. Yep, I think it's in there. So let's push them in. So now if I rotate this BLDC motor, we can see the upper part of the robot rotate, and this is a good sign for us that the hex stand has gone into its place and everything is almost tight and snugged in a good way. We are gonna use this dinosaur tool now. It might get a little loud, and I'm gonna use this too because it saves a lot of time. If you don't have one, of course this is really powerful. I would recommend you to get a less powerful version, or the one that is the torque is specified for these kinds of 3D printed parts, but we only have this lying around, so we're gonna proceed with this. And just be careful not to overdo it. It's really easy to break 3D printed parts. And you need to go in diagonal fashion to put this together. Yep, so we need to push this together, and then yeah, we need to really, you need to really push it together. More. Okay. Yep, and these remaining two sides.
Very carefully. We don't want to overdo this.
Yep, so. Okay, so this part is ready. Next up, we are gonna attach the next actuator over here. It's gonna be a 5010 actuator, and let's proceed with that. Is it like really difficult to move it, or is it like moving easily?
It is a bit difficult, and it also makes some clanky sounds.
I mean, the 6012 does make these kinds of sounds when moving. Yeah, but if we get to upload code on this, we'll figure it out if there's any problem or anything like that.
Yep.
Yeah, so going good so far.
Yeah.
And next up, we are gonna attach a 5010 actuator here.
I'll bring in the other part which we need to attach now. I think it's this one.
Yes, so we need this part next, I think, and we are gonna try and align it over here to see if the holes line up, because there are multiple parts that look exactly the same but are kind of different. And yeah, for this part we need M3X20 screws, and they are not mentioned in the bill of materials, but we had some of them lying around in our lab, and we're gonna use them to put this together. But if you're building this robot you're listening to this, you need to order M3X20 screws for this, because they're not mentioned in the bill of materials. I'm gonna find them in my lab now, just give me a second. These are not the correct ones. Yep, so as you can see over here, I have these M3X20 lying around in my lab, and they were not mentioned on the bill of materials, but you do need them to put this thing together. So I am gonna place these screws like this in there. So this part needs 6 of them in total. I'm gonna be attaching them. So I think we need 6 times 3, 18 in total. I don't think we'll have 18, but we'll just decrease the number of these screws as we move on with the assembly.
Yeah, we can always add more screws once we purchase them from when the markets open up. But for now, we just because we want to assemble the arm, we can go with the bare minimum amount which is required to hold the arm together.
Yep, that's what we are gonna do now. Yep, so now once I have these screws in there, I am gonna align them with these 6 holes over here, and I am gonna put everything together. So this is what it looks like. It should be able to rotate like this. So I'm gonna tighten them now. I'm gonna tighten them a little bit using this screw just to make sure they sit in their place. Then I'm gonna use the automatic equipment for it. Okay, I don't have the patience for this. I'm gonna bring in the.
Just 1 second. Can we quickly just make a video? Can you just pick this actuator up and rotate it just like you were?
I mean, we can do that safely after we. Okay, now I'm ready to.
Alright, just a second. Just give me.
Yep, so once it is put together, we can rotate it like this.
Rotate it now. Awesome.
Okay, so now we are gonna attach the next actuator inside this frame. So it's gonna be a 5010 actuator. So let's move on with that part of the assembly. Actually, what is the next in line? We need to make sure it's the right designation for this joint. All
Yeah.
of these have been calibrated to be in specific locations on the arm, so we cannot just randomly pick any actuator.
Okay, so I have written the right orientation. By the way, there is a community Discord server where all of these details are have been shared by some amazing people in the community who are working on this project, and I have just learned from there. So we're working on the left arm. In the left arm, this is the order of the actuators. So first of all, the M6C12 one, which we have over here. This one is 0 upper arm XL. The next one which comes after this is 1 upper arm YL. So this is the one, I think this is the one that we just calibrated right now.
Yep.
So
It's
1
gonna be that
upper
one.
arm YL.
This is 2 upper arm ZL minus ZL, something like that.
ZL. So this one comes in a
Not
bit
this
later.
one. This is XL. So where the hell is YL?
1 upper arm YL, the one that we just calibrated. Where is it? Here it is. Here, this is the one.
Okay, so yeah, this is the next one in line. This is gonna be the next one in position on the arm. So we are gonna be putting this thing together, and we have to disassemble this part for it. And so first up, what I'm gonna do is I am gonna disassemble this, and I'm looking for a screwdriver, the green one,
The green one.
that pesky green screwdriver.
It was somewhere over here. It's not here. Maybe.
Okay, never mind. I'm gonna try with tweezer. So I am gonna open this up. Okay, it came off nicely, and I'm gonna do the same for the opposite side. And let's do this. Now I'm gonna push this out. So it came out nicely with its bearing. So we're gonna need this unit. I'm gonna safely put it to a side. Let's remove these actuators from this so there's no confusion. And I'm gonna move the camera slightly downwards, and I'm gonna bring this a little bit in the frame like this. So yeah, we have these two parts. Yep, this part, and we are gonna be inserting this part through this hole like this. So let me just double check once. So we need to, I am gonna pick the bearing from here, and I'm gonna attach this bearing over here like this, and then I am gonna grab so these are M3X60 screws. So I'm gonna put them over here like this. And the last one goes like this. So we have 4 M3X60 screws over here, and then we are gonna put it in this arm, and we have to be absolutely sure about the orientation. I think it's this orientation, right? Yep, it's this orientation.
Yeah. So the motor part needs to come from here.
Yep.
It needs to be inserted from here, and the other part.
So yeah, I'm gonna put it
Yeah, this
through
is
here. Okay, it's gonna be a little bit of struggle, so I'm gonna put it down and try to push these through.
Yeah, it always takes a little bit of struggle to align the screws with all of the holes. It's not too difficult though, just needs a stable base.
Yeah, it just needs a little bit of focus. Like, you can't just bring it closer to the camera and align them at the same time. It's difficult to do. Now I am gonna use a little bit of force to push them through in there. So what I'm gonna do is I'm gonna spin them. Like this, like so. Yep, so now it's in there. So now we can force these screws all the way through. So I'm gonna use this again and push them yeah, so they need to be somewhat loose because you need to attach the motor to the other side.
Yeah, with that.
So what we need to do is
insert it.
yeah.
Like this
So
over here.
we're gonna pick this part up.
But there's a slight difference. We need to remove this bearing because it
Yeah.
over there. Like
So-
this, yeah.
So we are gonna grab this part now, and we are gonna push it through from this side, and we are gonna push it all the way through. So the gears are sitting in there, and we need to make it flush over here on this side. The next step we need to do is we need to grab the other part, which is this part.
Before that, the bearing and
Yeah.
make sure the screws up. By the way, we would love to know where everyone's tuning in from, and if there's any interesting projects that you're working on, or if you would like to have any discussion related to the tech space or software or robotics in general.
Okay, so the bearing is in there.
Yeah, just make sure it's snug in tightly.
Yeah, and make sure this part is also snugged in tightly. Now I am gonna push these a bit back now, and the reason for that is we need to align this motor with this part of the actuator with this part. So I'm gonna remove the CAN bus wires, and then we are gonna align them like so, and we need to apply a little bit of force to make sure they sit in their place. Aligning them is almost all. Yeah, so we skipped a step. Yeah, so sorry. So
Yeah.
once the bearing is in there, we need to also put this part, this cap or this lid on in there.
Yeah, while aligning the screws.
Yeah, so now we have aligned this as well, and the bearings can be pushed through. Now we are gonna proceed with joining the actuator, the two units of the actuator. So yep, now I'm gonna grab this and I'm gonna try and align this. It is a bit tricky and difficult to do, but it's not the most difficult thing in the world. Yep, so now they are aligned, and we need to screw everything together now. So I'm gonna bring in this tool once again, and I'm gonna use it. Yeah, I think the way this assembly is going, we are gonna use clips from this live stream to make the arm assembly video
Yeah.
for the series. So yeah, now this actuator is sitting in there. Okay, so
just rotate it a little bit for the voice. Just for the voice. It looks pretty cool.
yeah, the sound it makes, it's so satisfying. It's so fidgety, and it's so satisfying. Yeah. Okay, next up, what we are gonna do is we're gonna attach one more actuator from where this actuator is coming from. So it's gonna be one more degree of rotation over here. So we need to bring in a new part to put this together.
Yeah, so it's gonna be 2 upper arm ZL. This is this one over here, 2 upper arm ZL. So first of all, let's just tape it.
Yep, so it's this actuator, and I haven't properly joined this over here. We're gonna use a double-sided tape for it, so I'm gonna quickly do that now. Yep, so there is a trick to double side taping it on top over here. You cannot tape it in random direction, and I am gonna explain that in the live stream video. I haven't taped it yet. Where's the
Just
double?
make sure the orientation to tape it in. Then
Yeah. I know the orientation, and I'm gonna tape it in that orientation. Where is the double side? It's over there. I'm gonna grab it. Double-sided tape, probably the most helpful tool in this whole assembly process. So this is like the last roll. You can see we're almost out of it, but this thing has been like such a lifesaver for this project. We can make so many controversial Twitter posts regarding double-sided tape. Like I'm sure a lot of people will agree with how helpful double-sided tape is, and the ones with their pesky, really precise lab equipments, they're always gonna say like, no, this is not how you do professional work. Da da da.
yeah, it's kind of like debugging in software with a hello world or print statement debugging.
Yep.
Instead of using the proper debugger properly.
So yeah, guys, I've attached this motor controller over here, and it is ready to be attached on this arm, but we are gonna need another tool for this. So we're gonna bring in this tool, and what we're gonna do with this is I imagine we are gonna attach it like this. So that's why the orientation in which you attach this motor controller is really important. You cannot tape it on top of this actuator in any random orientation. This is gonna sit like this. So there's a channel for this, so it's gonna sit like so on top of this motor controller. So you cannot have it in any random orientation you want to. Once you this just got loose. We're gonna have to resolder this now. I think we'll have to ultimately detach all these components, and we'll have to resolder them. Guys, off to a slight resoldering detour, a resoldering intermission in the live stream.
Yeah, it's not gonna take too long. We'll quickly just wire up this holder and have this part attached once again, because once it is attached, there could be a danger of this coming off, and it'll become
Yep.
really difficult for us to disassemble all of the part and resolder this
Yep.
once again.
And by the way, we are trying to rush through this assembly process to finish this live stream series as soon as possible, and after that we are gonna be chopping this up, opening this, and making all the connections more stable and more robust. We're just like sprinting this process just to document everything, and then we're gonna be taking our time, making sure everything is ready to go and everything. Yeah, so we're just rushing through this for this the YouTube playlist we're gonna be making for this. It's our 11th live stream, and we have, I think, skipped like 3 days maybe. So all in all, we have like roughly 14-15 days worth of work over here. But people that actually build this robot, they spent multiple weeks and sometimes even months building this robot, and I I think that's the right way to go about it, because it's not a, I wouldn't say it's too difficult, but it's not like in a beginner territory in terms of projects. You have to make sure all the wiring connections, everything are on point, so you don't when you're facing any issues on the software side, or debugging robot, or adding trying to do different motions with your robot, you are sure the wiring connections, everything, the CAN bus, all the soldering is perfect and on point, then you can focus your attention on the software side.
Yeah, by the way, these arms, once the arm is assembled, it looks really amazing in real life. The camera really does not do it much justice, but seeing it on the table, once it's assembled, is really awesome. It's worth all the effort that we put into the last 10 or so live streams. Yeah, once the actuators are assembled, the assembly of the arm really does not take that much time. The most time consuming part is building the actuators, joining them all together, and then calibrating each one of them, because there's 22 of them in total. That's a lot of repetitive work. So all of the actuators are almost similar, but it's just that the number is too much. It's 22 actuators in total, so that really takes up a lot of time building all of these. But once all of the actuators are assembled, then assembling the arm really does not take too much of time. I hope we'll be able to do it within this live stream in front of everyone pretty easily, and in not much time. It's not gonna take too long.
I think the solder has heated up.
Yeah, hopefully the
A bit.
solder has heated up. Let's try reconnecting the wire.
Yep, so this is really not enough to like hold it
Together.
so,
Okay.
can you grab the solder wire from behind?
It is. The weather is changing here in Japan, as I would assume it's changing for most of the countries around the world. But yeah, many people are catching cold just because of the changing season. I was also pretty ill for the past few days, but now I'm feeling much better. I've been recovering for a few days, but today I'm feeling much better. it's gonna get more and more cold as the days go on till the end of October, start of November. It's gonna be the fall season. The color of forest trees, they're gonna start changing. There's a lot of tourism during this season in here in Tokyo and around Tokyo. But
Yeah,
yeah,
if you ever want to visit Japan, like spring and fall are the time to be here. In winter,
Yeah.
it's too cold, really cold, unless you're like really coming here for skiing.
especially the countryside, it's extremely cold, and it's a lot of snow in the countryside.
Yeah, it's not good for traveling in winter. Like it's too extreme, and is same for the summer side. Summers here get so humid, so hot. It's like no matter even if you are like not affected by summer at all, you're not gonna be able to enjoy traveling here in Japan because it's so humid. It messes up everything.
Yeah, so just a think about how hot Tokyo is, or Japan is in summer. Many of the Japanese people living here, they just fly off to US or Canada during summer just to avoid heat. So it's a very common thing here in Japan that Japanese nationals, they fly out in US or Canada for tourism for 2 to 3 months, just to avoid the heat. It is so hot over here, and this year it was our first summer here, and we could see why it really gets hot here. I think these wires over here, they're pretty spread out.
Yep, so let me try and lock it because I don't know why it doesn't seem like the right
I mean,
size
you can
part
try this
even.
one.
Yeah. You know they're both the same, but why are they both for the same purpose? Yeah, they both look exactly alike. So now we have to try to move this around to get these two to fit together, and what we need to really try and do is to keep yeah I kind of figured it out. I think so, or I hope so. Yep, it's kind of figured out. I would say so. I think let's remove these connections once. Yep, yeah, imagine if this. Yep, so there's a connection going short over there. So we have to remove this extra bit of wire that's jumping out of the blue one. Can you see it? Yeah, I'm can you grab a nail cutter from that drawer? So some of these connections, they really don't stand the test of double-sided tape. So a few strands for one of the wire got exposed when I removed the double-sided tape. So yeah, you have to be careful with your connections, and most importantly, you don't have to sprint through this entire project the way we are doing. I highly advise you not to sprint this project. Okay, so now what I am gonna do this time around is, first up I am gonna place it in there like so, and once it sits nicely in there, I am gonna proceed to align these holes roughly, and then I am gonna place everything together. So it's gonna look something like this, and let's fasten these using these screws. So I'm gonna put these screws over here. I think we need longer ones for this. So we need M3X30
30 ones because they need to
Yeah,
come out
so-
at the bottom and they need to be screwed in.
Yeah, so we really need to like align them and push everything downwards, and yeah, it's just a bit, it just requires a bit of patience. Yeah, if anything, it just requires a bit of patience.
Yeah, I think for the arm assembly, this part is the most difficult one to join.
Yeah, just the most time taking one, I would say.
Yeah,
For
just,
sure.
Yeah, just time taking one.
I am gonna push this one slightly in. So yeah, it's like the channel for the motor controller to sit in, it's not really wide at all. It barely fits in there, like really barely.
Yeah, I'm not sure about the software side later on, uploading the software policy to the robot. But if there is a part where we need to change this knob of the VLDC motor controller board, I presume it will be difficult for this part because it's very tightly snugged in.
Yeah, I think we can start inserting the
The nuts.
M3 nuts, and I have a bunch over here, and we need to put nuts. Oops, I just dropped it. This nut over here, so I'm gonna try pushing it over here. Okay, it just dropped in there. Yeah, where's the tweezer? We need to grab it.
Here you go.
Yeah, so yeah, this part is the most difficult and a little bit annoying one because it requires a lot of patience and care to put together, and there are two parts like this in total in arms, so we're gonna have to deal with another part just like this.
By the way, guys, a fun little thing in our live stream. There's a small, sort of a character moving at the bottom of the live stream, and if there is a comment on the live stream, if someone sends a comment, then their avatar will also appear along with the comment. It's a fun little feature which we have added, so you guys can try adding any comments if you want to, and a character will appear at the bottom of the screen with the comment, and that will be your avatar. So feel free to ask any questions or share any thoughts if you have regarding tech or anything in general. If you want to discuss anything or share any thoughts, feel free to send a comment.
So I just dropped a nut in there, and I'm not even sure where it is at right now. Yeah, this part gets so like what do I even call it?
Yeah, it requires a lot of precision.
I think it's here. In the wildest place imaginable. This is where the nut that I just dropped was sneaking in. Like, it's not even magnetized to the motor. It's just hiding in between these two 3D printed parts. Like, it's trying to annoy me personally. Like, I don't even understand how it made its way over there. Okay, another one done. Now I'm gonna move it closer to the stream to show this one and this one. So similarly we have to do all the nuts. We have to do the same for all the nuts. So I am gonna now proceed towards the back side, and I'm gonna try to push it down a bit. This part is so precise that there is a good chance if you are too like forceful with it, you can break the motor controller if you apply too much force over here. I think let's put together the aluminum profiles that came with the bill of materials, like the rectangular unit, and then use some sort of like DIY or hack method to
because if we can use the aluminum profiles which came with the bill of materials and create sort of a chest frame, then both arms would look really amazing on that, and we would be able to get really good shots and videos with that. That would really make all of this effort and night worth it. Yeah, let's definitely try to do that by the end of this live stream.
Yep.
Yeah, once again, this part is the only part in the assembly of the entire arm which takes most time. It's not that difficult per se, you just have to insert a few screws, but it requires a bit of precision and it takes a little bit of time. So it's just a little bit tricky in that sense. But the rest of the assembly, it's pretty straightforward. Hopefully it will have the other arm ready in no time, and we can move on to the aluminium chest frame of the humanoid robot.
And I'm almost through with the process. I'm just doing it off camera, so it's a bit quicker to do. You really have to lean in and be careful, otherwise you might drop the nut and it magnetizes with the motor, and then you have to grab it using a tweezer or something. Okay, so only two more to go, and then I'm gonna bring it in the camera and I'm gonna explain what I just did. I'm gonna attach those two together, and they are the easiest ones. So I did the most difficult ones early on. Oops, dropped it again. Oh man, it's gonna be there. Yeah, if you drop your nut in their motor, it's like a Where's Waldo sort of situation. It becomes really difficult to find it.
Yeah, if both of the parts were not tight enough already, they're already too tight, and then you miss the nut somewhere in between.
Yep, so I need the bigger head for this. And yeah, almost done with them. I just have to tighten them a bit, and then I'm gonna explain. Okay, so yeah, sorry for doing that off camera. And what I did exactly was I placed these nuts in there, and on the we had to get them through on the opposite end over here, and we had to place these M3 nuts. So as you can see, these parts are all around this unit, and they are placed firmly in there using M3 nuts. So yeah, getting them all in there, it's a bit tricky, and you have to like really lean in there and get it. uh, it's a sort of a precise job, and you need to make sure these CAN bus wires are available, accessible from one side, and from the other side of the channel you have these power cables accessible. So yeah, this is the unit I was putting together. So this is a M5010 actuator, not like M just 50, and this is the unit we are gonna put together over here now. Okay, so the next step is to grab these two components and align them this way. And once again, if you are building this robot and you're following this tutorial, you need for this step M3x20 screws, which are not mentioned in the bill of materials, so you need to be careful of this. And if you are doing this on a really flexible timeline, you can go ahead and order them, wait for them to arrive, or grab them from your local hardware store or something like that. But yeah, we were really lucky in this sense. We had these lying around in our lab, and we are gonna use this to join this together over here. So I'm gonna align them, and I am gonna tighten them using this one this time. So let's do that. Okay, I'm gonna bring in the automatic equipment now.
So for anyone who's been following this series, they would know that bill of materials has been a huge issue for us. Some of the parts arrived pretty late, and some of the parts we were just not able to get. We simply did not order because we were not expecting them to arrive in the right time. So for the arm of the robot, this is what I'm gonna be showing in a moment after these screws are done.
Yep, so just give me a second. So now this part has been attached, and you need to make sure it can rotate like this. Okay, now you can.
It's making weird noises. So is it?
I mean, is
it smooth?
Yeah, it's really smooth.
Okay.
But it does make these kinds of fidgety noises.
That one doesn't.
I mean, it does. Yeah.
This one is pretty.
Actually, it doesn't.
Be very careful with placing.
Then I think we can loosen them a little bit.
Yeah, just a little bit.
But it is still gonna be making those sounds. I'm pretty certain.
Yeah, but for the end of the arm, the very hand of the robot, we quickly just picked this part up because we were not able to order the original part which was mentioned in the BOM in time. So we just quickly grabbed this, and I'm gonna be unboxing this, and we'll see if we can use this for the hand of the robot or not. In the latter case, we would need to order the original BOM part for the hand.
Okay, so I have loosened them a bit. It's still making those noises.
It's fine.
Yeah, I think I mean, but no, making them loose is really not a good idea because you can see there it introduces a bit of play over here, so we don't want that sort of play. So I'm going to tighten them again.
Just a little bit, not too much.
Yep, I mean, no, as you can see over here, there it's still.
Okay.
Yeah, it's also making the same noises, so I think it's pretty normal. Yeah, it's probably the sound from those gears.
Yeah.
I think so, but in this case, it's still not fully locked in. So there's a lot of play here that we need to sort out. I'm really not a big fan of these four-headed screws. It's so easy to get them messed up while tightening them.
Yeah, and then it becomes difficult to take them off.
Yep. So
Yeah.
I'm gonna use a really good screwdriver with a really good leverage to tighten them. I'm not even gonna be using this equipment for it. It's so messed up. Yep. So. Yep. I don't think there's any play anymore. So as you can see, it's pretty tight and locked in, and
Just
it's able to move.
just one more time. I think it's gonna be a very cool video. Just one more time. I want you to show this side with the driver because the driver looks really cool. Yes, like this. Grab it like this. Okay. And turn it horizontally, like this.
Okay.
Like this. Yes. And now just rotate the. Just a second. Yes. Just.
I mean, just a second.
Keep it that way. That's
Okay.
fine.
It's
Just. All right. Now rotate it. The videos are coming in pretty good.
yeah.
Pretty good.
Okay.
Yeah.
So
Quickly, by the way, this is an entire Arduino kit. It's not just the part for the hand. It's an entire kit, and it has a lot of parts. So, like, it has this OLED screen. It has a lot of hex stands, screws, nuts, and bolts. It has other parts like these discs, which can be attached, and many other. So it has a very small servo motor as well, as you can see over here. And frankly, I don't even know how many more parts are in there. It's an entire kit. I forgot what was the price of this because it has a lot of parts inside of it. It's a pretty universal kit for microcontrollers or Arduino in general, which they have mentioned, but microcontrollers, of course, in general, it has a lot of different parts. But what we're interested in is this specific part. If we can use this as the arm, the hand of the robot or not. So I'm going to be unboxing this, and we'll take a look. By the way, we saw someone watch the live stream of Battlefield today, right?
Yeah.
It's obviously quite famous. Many live streamers are playing it at the moment. I was just comparing the dopamine or levels, or the action pace, or the amount of things happening on the screen with Battlefield and this live stream. There's
Yeah.
almost no comparison.
Yeah,
Like,
it's
it's worlds apart.
yeah, and Battlefield just blows us out of
Yeah,
out of the
it's
waters,
it's
yeah.
it's an entirely different universe altogether.
Yeah, like people have to be really interested in they need to be really into this sort of stuff to
Yeah.
enjoy our live streams, and I don't think there are many people like that.
But however, I do think that our live streams could be made much better with a unique artistic angle or sense.
Yeah, for sure.
So
for
like
sure.
it's just like the 80-20 rule, or I would say 99-1 rule. It's like so extreme. Not many people put in efforts to make this their live streams or their entire production or their storytelling. There's a lot that can be done to make the overall presentation really great. And it's very common with live streamers or people that they have videos, hundreds of videos after 1 year, and it's just there's no progress at all. They've just recorded videos and very few subscribers.
Okay,
So
can you make sure which 5010 actuator is next on
yeah, you
the
can check
next
check
name?
on that list.
Okay, so we are building the uh, left
By
arm
the way,
of the robot, and
yeah.
I think it's XL.
Check this.
Oh wow! So
I think
there's a
there-
bunch of gears and yeah, this is acrylic sheet, right?
Yeah.
So yeah, so this is sort of like what they call those
Like
the robots, the puzzle pieces robot sort of thing. I'm totally missing the name of but
Yeah,
it's
kinda
so-
like,
it's
but-
something like that. DIY sort of parts.
sort of like Lego blocks or whatnot,
Yeah.
which you can open up and build parts like this. I think the entirety of this arm can be made from these pieces.
Yeah, I mean, of course, that's what they're like advertising on the board. So just to be sure, the next one is the XL, right? Yeah, yep, I got it. I got the one. Yep. So
This kit has
This-
hordes of servo motors.
yeah, this is the next one in the series we are gonna attach over here, and it's gonna be attached at an angle, and we are gonna be needing another part for that, which I'm looking for right now. So where's the next sort of that? So, yep, it's gonna be this one. So we are gonna need this one, and we are gonna put it on here like this. So I am gonna I'm gonna grab a few of these, and I'm gonna insert it over here like so, and I'm gonna grab this one as well. Two more to go. I'm gonna put it in there. Okay, so this I have attached these screws in there, and I'm gonna grab this one, and we are gonna align this on top over here, and then I'm gonna use this to put them in their place like this. Where, yeah, here you go. So you need to make sure you're tightening them firmly, otherwise there is gonna be clankiness in the joints of the robot, and the motion is not gonna be really smooth. So you need to make sure they're firmly sitting in there.
Yeah, so these BLDC motors, they are reasonably strong. They have a very good torque and very good RPM as well. So if all of them are moving through the policy or whatever software that you have uploaded to the robot, you want to make sure the parts are tightly knitted together, so the motion comes out very smooth. And this is especially important with the operations where precision is important. So some of the commercial robots, which are performing household tasks like cleaning or picking up something, glass or whatnot, or folding the bed sheets or whatnot. Precision is really important for those robots. So the feedback from the motors, it really needs to be precise for the machine learning algorithm to accurately do the job correctly.
So I'm gonna open up this now, and we need to disassemble it to put it in here. These screws are really nice. I think they came from China or something like that, but they're really good.
Yeah,
Surprisingly, they're better than the Conan ones.
That's a really good thing. That's a really good. So earlier I was watching a video regarding of someone who has been running 3D printing business for a while, and he was a really successful person, and his overall video was very good, very interesting to watch. I think
wow, I kind of messed this up,
you can just pull this one out.
but I'm gonna have to like put it in there, you know. I'll have to disassemble the whole thing.
Yes, earlier I was watching a video of someone who has been running 3D printing business for a while now. He was just sort of sharing his lessons along the journey, and one of the things he mentioned was, if you're planning to do something like this for a long time, do not compromise on the filament quality at all, ever, because he'd been doing this for years now, so he had a lot of experience, and he said it's totally natural and common to expect that 3D printers will break. They will break. The best that you can do is provide them with best materials and maintain them occasionally to maximize their longevity, because you will need that once the productions once you're ramping up productions, or there's a lot of orders which are in stock. So yeah, there are a lot of options available for cheap 3D printer filaments, but that's really something you do not want to go for. If you've invested so much in getting a really good 3D printer, you want to make sure that the filament quality is good and you do not mess up the nozzle of the printer.
Okay, so this one was hot glued. So that's why it was really difficult to get it in there. But I think we can use this one as well. Like I can just shove it back in there.
Yeah, let's try to do that.
But yeah, I'm gonna try and attach it.
It's very
here.
tightly joined together. It's almost a hard soldered part.
Yep, no worries.
Yeah.
It's not like we're gonna need to. Okay, I'm gonna put it back. Yeah, see this
Yeah.
hot glue, it makes its way everywhere. Okay, so yeah, finally I'm done with that. So the next step is to gather this piece over here. I'm gonna grab this part and we are gonna insert four holes through, sorry, four screws in there. So these are gonna be M3X60 screws. We're gonna repeat the process we did on this limb over here. We are gonna repeat the process for this one as well. So I am gonna rotate this and this way, and so once again I'm gonna grab this part and I am gonna align these four holes like so, and okay, so I have attached this unit and the bearing on this side, on this end, and now we are gonna insert this unit from the opposite side like so, and I'm gonna bring it in. So we need to make sure it's perfectly aligned. And it's not aligned, damn it. I'm gonna have to remove these and try again with the alignment. Okay, and let's not even like remove it necessarily, just want to make sure it makes its way through this unit, it sits in there nicely, and if it does not, we will have to change its orientation.
Yeah. The world is full of so many amazing places to travel to. A while ago, I was looking at the Siberian winter, the one we checked earlier on back in our country. Siberian, it's extremely brutal and just covers practically the very earth in snow. All of it is frozen. And it's a pretty interesting place to travel to and experience. But just because of the political situation and the war that's currently going on, I wonder what's the access over there. I would assume it's close to impossible and dangerous as well to travel there during these times.
It finally went in.
You do you need to put? Oh, okay. After this, you need to put in the bearing, right?
Yep, after this.
Okay.
So I am gonna tighten it this way, and then we are gonna. this overall this project has been like so much fun in terms of just understanding what the the basic building blocks of a humanoid robot are, like actuators, cyclodal or universal planetary gears,
Yeah.
things like that.
Yeah, and this one did not even take that long to build. Just the material sourcing was the most time taking part, but in terms of assembly, it really does not take that much time, because all of the parts once again are very well documented. They have a very detailed BOM documentation on hardware, software, electronics, all of the components about this robot.
Yep, now comes the moment of truth. If I'll be able to align this and put it in there. And this actuator is gonna be the most fishy one out of all of them in terms of if we will be able to get it to move nicely or not. It seems like it's locked in there pretty nicely. Just if you try, yep, it's rotating. So I hope it doesn't break or anything. Like if there is a lot of torque on this unit, I'm gonna need a smaller one. Where's these units?
Just a second.
One of them is here, but it's really small.
These ones?
No, I had them all, the ones I needed, out here somewhere.
There's one over this one?
No.
These two?
Yeah, there's a size that's bigger than this one. Let me try and see if this one is not working.
Oh,
Yep.
here we have one.
Yep, this is exactly what I needed. Okay, so this part is also done, and next up we are gonna move to, I think, what's the last actuator? How many do I? It's the last one, right?
Yeah, I think this is gonna be the tough one, the one where you need to.
Okay, gotcha. Yeah, so I am gonna need one more of this. So we are gonna grab one more of this module and
Just confirm if this is the one.
ZL, yes, and we are gonna put it in there like this. And once we have aligned everything, we are gonna do the exact same thing we did with the last one. So we are gonna struggle for a bit with this one as well. Okay, so it seems to be sitting in place, so I am gonna try to make use of it, and I'm gonna try and start inserting M3X 30 screws in there. So let's first try to get them all in, and then we will try to, what do you call it, yep, and then we'll try to fix them, lock them in their place. Okay, so it's gonna need a little bit of working, a little bit of moving around, like this. Same for this side. And yep, so like last time, I'm gonna move this off camera because it requires a bit of getting in there, tinkering around. So I'm gonna try to be quick with this, and I'm gonna show you the result, what it looks like. Okay.
The longest one I think is this one, the longest one. Yeah, I think so.
Which one?
This
yeah,
one.
the size. Okay.
This is the one. I'll be back in a second.
It's just a bunch of nuts that we are attaching to the actuator, and once again this part is a bit difficult, not difficult, just like annoying, and you have to be really precise with the placement of those nuts, otherwise they drop in the motor and the windings of the motor and they attach magnetically there. Okay, I have attached two of them, and but we have a few more to go. Let's grab a few more, and yeah, just we yep. I think we really quick soldering. I'm gonna have to fix that now. So another quick soldering intermission. Uh, I'm gonna place it here, and I'm gonna attach the solder iron, and I'm gonna wait for it to heat up, and then we're gonna reattach the wire. Once again, what we are trying to do with this series that we're building here, the live stream we're doing, we're trying to put this thing together as soon as possible and try to get it moving, but after that we're gonna be disassembling the entire thing, and we're gonna be making proper connections using these connectors and everything. Right now the soldering and the general assembly of the robot, it's really rushed, and you don't want to be rushing this kind of project. But we're just trying to document the process, trying to make all the videos, and trying to get this thing to work. And after that we're gonna go through the entire thing again, go through all the actuators, the motor controllers, and the encoders, and we're gonna make sure the soldering and everything, the connections are all good. So just a bit of progress while I wait for the solder iron to heat up. So far, before starting this live stream, we made the right hand side of the robot's arm, and now in this live stream we are almost done building the left arm of the robot, and this is actually the last actuator we have to attach to do this. And once we're done attaching this last actuator, we'll have two arms of the robot ready, and we are getting these aluminum profiles ready to put together a loose skeleton of the upper part of the robot's body, and we are going to be doing that live in this video, and we will show you what it's going to look like, and hopefully I think it's going to look pretty sick. Like after all those days grinding the soldering, wiring, the encoders, everything, grinding on live streams. Yeah, this is the 11th live stream. So we have done 10 of these live streams before, and most of it was just repetitive process over and over again. But the finished result, it looks really sick. And for like 10 live streams and 10 days of sprinting, I take this any day of the week. The end result, the progress we have made so far, it looks really worth it. So yeah, we are just waiting for this solder iron to go live, like to really heat up, and then I'm simply gonna reattach this wire, and I'm gonna make this connection somewhat stable. We're not doing all the way through perfect soldering at this point. At this point, the priority is to just put something together, and of course, like really loose connections made, and try to move some joints. And after that, we're gonna go through every single motor controller again, and we're gonna make sure all the wiring connections, everything is stable. I would also prefer removing these voltage cables and attaching cables with connectors on here, so everything is modular. We should be able to remove any actuator or joint from the process if we want to, but because of the rush, we are doing hard soldering. We're doing permanent connections this time around. After that, we're gonna be cutting these wires, and we're gonna make those connections modular like I just discussed. And yeah, the people, the Berkeley Humanoid Light, they have a really cool Discord community, and some of the people are actively building robot in there, and they've been at it for months, and it's a really good practice to set aside a time for this robot and to make sure you're moving through every process slowly and gradually, so every connection and everything is perfect. If you sprint through it like this, like in 10-11 days like us, you're gonna have to come back and make sure a lot of these connections are solid, because if this robot is gonna be jumping around, moving around, working, and you're gonna be testing a lot of policies and algorithms on this robot, you need to be really sure all the connections and everything is stable, so you can do whatever you want to do with this robot later on in the software stage. So yeah, I think the the soldering iron has heated up, and I am gonna try to make this connection a bit more sticky this time, so it does not like come off like it did. And hopefully when we circle the live power wire through these actuators, hopefully they work. If any of them does not ends up not working, it's not a big deal at this stage. Like I mentioned, our goal is not to make all the joints movable, although with the wiring I've done, I hope probably all the joints will move, but even if a few ones move, we just need to get the basic layout of all the CAN wires, the power wires, and all the actuators on both the limbs of the robot in place, and then we can sort of move through all the motor controllers one by one, and we can improve the wiring, the connections, everything. We can make them more permanent. I think we're gonna have to add a lot more solder over here, so the connection ends up being perfect and it doesn't like just fall off. And there are a lot of SMD components around this board. Once again, this board is really small, so you need to be sure not to uh, make a short connection with any of the SMD components when you're trying to solder in your wire. Okay, I am gonna check this connection now, make sure it's stable and everything, and then we are gonna proceed with the assembly of the arm of the robot. Let me just check it to make sure it's good. Yep, it seems pretty solid this time around, and I don't think it's going anywhere. And I'm gonna detach the soldering iron now just to be safe, and I'm gonna move it to a side. It kind of wasn't in the frame, it was like really at the side, but you know what I mean. I'm gonna now what we need to do once again is I am gonna grab this actuator, which is the last actuator, and I am gonna grab this component, and then we are gonna loosely align these two parts, and I am gonna make sure to I'm gonna make sure to keep the motor controller board in this channel over here, so be very careful not to hurt the board, otherwise you're gonna have to order another board for this, and yeah, it's gonna take a while to be delivered to you. So yeah, it make sure it's sitting perfectly like this, and then you can simply attach M3 nuts on the opposite ends, which I am gonna do now.
How far along are we with the assembly?
Another power cable just came off, and I was just soldering that back in place. And I was just like explaining how we are only trying to get one or two limbs to move. Even if all the limbs don't move, it's not a big deal at this point. We just want to put something together, document the entire process, and make sure all the wire connections, they are the right way around, so whoever is following this documentation, they are able to build this thing at their own pace.
Yeah, and that's one of the things which really takes some time to understand, that projects, especially hardware projects, need some time to finish, because you're gonna run into all sorts of problems, like this one, whereby once you're iterating and you're building the project, you're working on the project, you run into issues and you find issues that you then need to fix, and it's a pretty normal part of the job. It's not even an exception in hardware projects. So that's why it's usually not a good idea to rush the products, especially if they need to be precise, and you want the build quality to be good, and you want them to be in operation for a long period of time. It is usually a good idea to have a decent amount of time allocated, and ensure that the quality is there. With rushing, you're just setting the product up for failure if you're just rushing on the project.
And another thing we discussed in an earlier live stream is how if the relation is not like a client relation or a subcontract, it's really difficult to stay motivated on a project after a few days. So that's why generally with the projects we do, and especially for in this case like the videos we need to make and the playlist we need to put up documenting this process, we are rushing through this just to document everything, not to necessarily make sure this robot can jump around, do backflips on the very first attempt. It's okay to have some loose connections and things like that. I just want to get this documentation process done as soon as possible. Otherwise, we're gonna move on to bigger, better projects after this.
Yeah, the ensuring that the connections are perfectly done comes a little later, because our deadline was a bit tight. So assembling it, we really did not have enough time to slowly take things. So we had to assemble everything pretty quickly to at least show some version of the robot which was assembled, and some proof of the hardware assembly.
Yep.
Yeah, but on the whole, for even besides this project, which is a really amazing project, and we're it's really good to see it all coming together. Even beyond this project, we have some pretty great and interesting ideas for this channel, and we're really excited to see how the rest of this year and the next year goes. We have some pretty amazing video ideas, project ideas in the line, which we're really going to be sprinting on. We're going to be pouring a huge amount of time and effort into them to bring really quality videos as well as products and projects out there. So yeah, pretty excited for the rest of this year and the next year.
Yep, and when we say quality, it's not gonna be like this, like just a simple camera and a bird's eye view camera. It's not gonna be like this. Like it's gonna be quality, and we're gonna start revealing those projects in a few weeks. So some plans are already in works with the videos that we are gonna publish on this channel, and I'm really excited for them, and I'm gonna start revealing them here pretty soon. For now, the tutorials that I have lined up, they are just generic tutorials, beginner friendly tutorials. So they are not the kind of, they're not necessarily the entertaining content that we're gonna be putting on this channel, but we have a lot of educational or tutorial videos planned like we regularly upload on this channel. Those are always gonna be coming in, but we have a lot of projects like the Squid Games robot we made, for example. Those kinds of entertaining videos as well planned for this channel, and hopefully you're gonna start seeing more of them in the coming months on this channel.
Yeah, it's gonna be pretty interesting, and yeah, there's a lot of things that we have in mind, and we're gonna be improving the quality, obviously, with each project.
Yeah, so I think the really long term goal of this channel is to have a lot of entertaining videos, a lot of like brain dead entertaining robotics related videos.
Yeah.
But we're gonna have a lot of audience interaction with them, maybe some sort of games and stuff like that. So the goal with those videos is to just attract a lot of attention to the channel, and then maybe some people they who'd want to stick around, who maybe want to learn about robotics and stuff. We're gonna have a lot of boring, bland, or not even like boring, just really simple to the point tutorials on these topics for them to watch and learn. But if they're just there for entertainment, we're gonna have playlists of those as well.
Yeah.
So I am going through the last screw for this process, and this is the last actuator we are building for the arm of I keep forgetting whatever side arm of the robot it is. And yeah, after that we are gonna try and put together the body of the robot, and I'm really excited for that. I'm really looking forward to see how it's gonna look. Oh damn, the nut just jumped in there somewhere. where the hell has the nut gone this time around? It's here, damn it. You can start unpacking this and start.
Yeah, I just want to make sure if this is the correct size, because
In
in
what
the-
sense? Like,
in the image it seems like the front size is very long compared to the side of the robot. This one seems smaller.
I mean,
compared with the
it
image.
won't even matter if the size of the chest of the robot is thin in our case. Like, it's still gonna be
Yeah.
like attached together. Right?
Yeah, that's true. That's true.
So you can just start the process, because that's where we will be able to end this live stream early on.
Yeah. Tomorrow also we have to be somewhere. So yeah, tomorrow is also a.
Yeah, tomorrow is a bit busy day. I don't know about live stream. We probably might be able to do a live stream. If we do something with the robot, we'll do a live stream. Otherwise, yeah, tomorrow is a busy day, but
There's a lot of moving factors tomorrow, and
yeah, let's wait to see how till tomorrow how tomorrow plays out. So we're not gonna be making any promises for live stream or anything like that till then. Yeah, you have to make sure all the wires are free to do as they please in there. You don't want to like choke any wire in the process of like putting this together. So I'm making sure of that right now, and
Okay.
then you can just
so which M size screws or the
I mean, at this point, I think you can use whatever size we have available, or whatever size we prefer, because we have the inventory of M5. You don't have to check over here. If we are using our own screws, they are all gonna be here, and for the remaining materials, they're gonna be on top over there. If you wanna use those. Yeah, I just had to add one more. We had to make sure to add this in there as well. Yeah, so now I think we can tighten everything together. Yeah, so you don't have to like, you don't have to over tighten it, but it can't be loose as well. So yep, so this is what this part is looking like, right? So the last step we are gonna do now to put this whole thing together is, once again we are gonna be using M3X20 screws, and we are gonna be adding these in there. And let me add a bit more of this. 2 more, right? Yep, so we were really saved by having these screws lying around in our lab, and we can say this for so many parts in this robot, because we're rushing through this project, and thankfully we had a lot of parts lying around in our lab. Okay, Ali, if you can grab the solder iron, and if you can get it yeah, get it connected again. We need to solder one wire over here, but that can be after. Just place it on that table. So it's, I'm gonna be attaching this meanwhile. So this is the last one we need to attach, and we are gonna attach it like this over here. So I am gonna align it like so, and then we are just gonna put everything neatly in place using this screwdriver. So I'm gonna So initially, I would like to use the parts we ordered as much as possible. So the parts, the spare parts in the lab are.
Yep. Okay, so you can grab them from above up there.
I already have them over there.
Okay. Yeah.
We have M3 size and M4 size. M3 and M4. Yeah. We also ordered the screws of different sizes. Do we know where they are? I think over here. Oh no, these are the wires which we got from the Conan Pro.
Okay, guys, I'm just gonna be back in a second. I need to solder one more wire on this hand, but after that it's pretty much ready. It's like ready to rock and roll. I'm just gonna have to solder one wire over here, and yep, let's try and do that right now. So let's disconnect this solder from here, and I'm gonna move it back, and we are done with the design, and I'm gonna move all these things to a side now, and I'm gonna bring both the arms in the frame in a moment. So I'm gonna do a little bit of housekeeping. I'm gonna clean up this area, otherwise it turns into a mess real quick, and we want to keep everything as efficient as possible. And these are the 61, so these are gonna go there, this is gonna go there, you can go there, and this one, I think this is a random one, it's gonna go to a side over here. These, I'm gonna put these in there as well, and I've been getting a little bit of soreness in my throat because of the changing weather as well. So yeah, this is the weather, like you need to be most careful in, like during the transition between
summer and
seasons,
winter.
yeah.
Okay, so yep, I think the table is clean, and let's move this to your side as well. So we have one arm of the robot over here. The big reveal. This is one arm of the robot, and I'm gonna move it slightly over here, and this is the second arm of the robot. Why does it feel like it's yeah. Okay, so it was the wrong way around. So we have both arms of the robot done and ready to go. Let me try to make them a bit more squished. So yep, like this.
Yeah.
So the wiring and everything, it's not perfect, of course, and I mean it would have looked much more beautiful if we twisted these wires together, and did all that beauty and that sort of stuff. But we're not focused on that right now. We also don't have the connectors to attach on the ends of these power cables, so we're also these are bare. These wires are bare right now. So yeah, overall, they look really beautiful. Like they don't look at even now looking at the stream, they're not looking as cool or big or robust on camera, but these, I mean, just moving them is so like satisfying. It's like such a cool thing to move and play around with. And yeah, the next step, we are gonna try putting this together on a body, and if it wasn't looking cool enough already, I think it's gonna look way more cool on when put together on a body. So we are gonna move to that stage now, and I'm gonna move these microcontrollers
Yeah,
and these
let's
small
start
devices.
putting the aluminium profiles together with the robot. We will need the 90-degree connectors and M3X some screws. Now with the M3X something screws, I would like it would be better to prefer the materials which we ordered.
Okay, yeah.
So like we got for a couple of different sizes. We'll see if they fit together nicely or not. And we do have M3 opened.
Yeah, I just want to look at a few pictures of this part of
Yeah,
the assembly.
Go building the robot.
Okay.
And then go down, go below.
Okay,
Go below.
let's try and
Entire robot. Yeah, click on this and then go quite forward.
Okay, so
Quite forward.
okay, so now I am able to see a little bit of what a semblance of what what the robot looks like. And okay, so I get the idea. So Ali, what we need to do right now is we only need to get these two in place, like the upper two ones.
Yeah.
And are they like connected in between them? Are there any aluminum?
Okay, quick question.
Yeah.
The one that's 90 degree to these, that seems longer than these.
And the lower,
Yeah.
the one that's going downwards.
Yeah, that seems longer. So like that would be this one, and maybe the one that's going on the side is this one.
I don't. Just a second. Maybe we can look a bit at some other views of the robot, like this. Okay. Now I think
I think it makes sense. Those are the ones which go downwards, and this might be the one that goes sideways. Can you compare the length?
Four, right?
Can you just compare the length like this?
Yep, I think just give me a second. 1, 2, And these are the ones that I think go
So like these are
between them.
no. I think these are the ones almost.
No, I think these are the these they're
No.
they have one attached over here, right?
Yeah.
So we need to attach something in between to kind of keep it together, you know. So they only have a single one in the center. Okay.
So like you can have. This is the same.
Okay. Now I get it. I get it now. And it's like it's gonna be like this, and then we are gonna put one like this, and then bring in a part that's about this. So yeah, this is the one that they're putting in the center. So what
it's
we
the
are
same
gonna
size,
do
isn't it?
now, the goal for the one in the center is just to hold up the robot, but we're not gonna be doing that, you know. So right now, to put these things together, we are simply what I recommend doing is making this one. We don't want to like follow the instructions as it is right now. uh there are two of these, right? Where's the second one?
On top of.
Yep. So let's just make this frame and attach one hand over here, and put hang this frame somewhere.
Okay.
And then we'll have one arm suspended on this side and one arm suspended on the other side. That's what we're gonna do right now, okay?
All right.
We are gonna figure out a way to suspend it somehow. Otherwise, the other option we can have is, yeah, we can just bring them a bit closer like this, and we
And
can
grab,
maybe,
grab them.
yeah, we can I wanna recommend like grabbing them. We can pass a thread through them,
And
or
then grab the thread.
yeah,
again,
hang the
okay,
thread
we can do
somehow.
that. And then just keep the distance. Keep the distance.
Let's just keep the distance
Yeah.
like this, and yeah, we can just attach it
Okay,
really
just
quickly.
remove these covers.
Yeah.
And yeah, let's start attaching these.
Yep. So we are gonna be needing parts from our lab once again this time, because to put this robot together really quickly, that's what we're comfortable with the most and we have the most experience with. I am gonna bring in a bunch of these, and Ali, I think to put these together, at least let's just use the ones we have available, the aluminum profiles and stuff like that. Give me a second to think about it.
These are M3.
Yep. Yeah. Is there gonna be enough room for it to? I don't think there's enough room even. It's gonna be a bit tricky and a bit difficult to get it on there, but we're gonna figure out a way. Just a second. How can we even do this? We will have to thread these parts, Ali. We'll have to thread these parts if we are gonna put it together the way we are trying to put it together. Or the other option we have is, if we do it like this.
From the inside.
Yeah, in that case,
Yeah,
we only need to put one over here to hold it up. Yeah.
Yeah, that's a good idea, I think.
Yep.
We wanna keep it
Let's definitely do this. Let's do this.
We're gonna keep it as less destructive as we can.
Yep.
So first of all, let's attach to 90-degree over here and here.
Yeah. So that's how we can start. Yeah.
Give me the other arm. I'll do it for the other one.
Yep. You can grab this. So guys, we are putting together these two arms on a single aluminum profile frame, and we're gonna see how it looks, how it comes together. And yeah, I'm really excited to see how it looks like. I'm gonna recommend using these, the ones we have, because they're the easiest to use.
They're M3, right?
Do what M3?
Or M4 as well. We have option for M4 as well.
You know, these are really difficult to deal with, but let's just go with them for now. Yeah.
M3.
No, these T-nuts, like man, you have to slide them in from a side
Yeah,
and then
yeah,
you
yeah.
can't get them out. They're like really difficult and stupid to deal with, but let's just do that. So we are using M3, right?
Yeah.
Okay, I am gonna get in one from this side and the other one from this side. They are like so inefficient for prototyping. Where are the screws for this?
Not sure. Like
Did
M3X, what size? We would need to find
any screws came with them like at all?
with these.
Yeah. Because then why are we using these nuts then?
We do have it in M3 or M4. So depending on whether we want to use from our lab.
I don't even think we any we ordered or we have seen any M3 or M4 screws.
I think
these.
along with these, we most likely would have ordered.
Yep, I did remember ordering them. I'm just not sure if I have seen them. I'm pretty certain we have not seen them. I think just like scrub the idea of M3 and let's just go with what we have in the lab. Which size is this? This is gonna be M4 I think, but I'm not too sure if even M4 is gonna hold.
These are M4 if you want to try in M4.
Just let me try this in this one. Yep, it's not working. But I don't think it's the right length. Let me see if it's the right length or not. Yep, seems about right. Seems about right. So just put these back in there, all of these, and let's move with the M4 ones. We're gonna use screws from our lab once again. It like always comes down to it, and yeah. And I'm gonna try and attach a M2 one over here. Yep, I think it will work. Yep, it will work. So going through the materials we had again, I know.
Yeah, throughout the process of building this robot, we've had to use parts from our lab on and off for various different hardware parts or assemblies. Once again, for the millionth time, it's a good idea to have your lab equipped with general tools and parts which are generally used with like aluminum profiles or 3D printed parts.
It's become like we're turned into a broken record at this point, but yeah,
just in this project it has saved us so many times.
Yep, so we need to put 2 of these in there. Bam. And another one like this. and then we need to add one over here, one over here, so in total like four of these. We're gonna attach that one later on, and I'm gonna tighten this over here. Okay. Where is the like longer screwdriver, the one that had really good leverage? Here we go, and let's put it in place.
Can you just pass me a normal one, the black one from besides? Yeah, this one.
And I'm gonna attach one more to this side, and the process is gonna be the same. And let's try and grab onto this nut over here, and we are gonna just lock it in place. So this part is ready to go onto this frame, and I'm gonna try my best to we can just add in these later on, but I'm gonna try my best to no do that. I'm gonna grab an M4 nut, and we are gonna lock it in like this. Okay, somewhere over here should be fine, and let's just fix it in its place. Yep, seems tightly locked in, and I think we'll have to release it a bit to accommodate for the other parts. And I'm going to attach the other one over here as well, and then we can attach the other part of the robot's body. The other arm of the robot is being prepared off camera, and just in a minute we're going to be bringing that one in, and we are going to be putting everything together. And let's just see how it turns out, how it looks. Yeah, I know they are turning out to be a bit tilted, and I'm gonna fix that in a second. It's ready?
Yep. We
Yep,
just need to
yep,
insert from this point.
yep, it's ready to go on here, yeah. Just give me a second. We'll get this thing sorted out. Okay, this one is pretty good, and I'm just gonna fix this one as well. I'm gonna loosen it a bit. We are gonna move it inside, and then I'm gonna attach it tightly. Okay, so we need one for the middle part over here, so we can grab onto this unit.
Mhm.
And yeah, so let's just prepare this part for now. So what we are gonna do is we are gonna throw. I'm gonna try to make it horizontal now, and it sits really nicely in there. And I'm gonna insert these over here for roughly where they are supposed to be. And yeah, the thing with these aluminum profiles is that you need to insert these beforehand. I'm gonna prepare this part now to go in the center over here, and then we're gonna attach the other arm on the other. And I think it's gonna look really cool. It's looking really good already.
Yep. It's gonna look really amazing once it's assembled. I think in about 10 to 15 minutes we will have the assembled upper body, chest area, and both arms of the robot. And it's gonna look really amazing. We will adjust the camera of the live stream a little bit to showcase the moving arms.
And three more to go. We're gonna attach one corner bracket here and then two over here on these sides, and then we're gonna attach it over here where they're supposed to go. So let's keep moving forward with this. And once again, these M4 screws for the corner aluminum profiles, I don't think they were mentioned in the bill of materials. So yeah, a lot of stuff is a bit find around sort of stuff while you're working on the robot. But if you do have a hardware lab, or if you've worked on hardware projects, you do tend to have these kinds of components just lying around, for example in our case. So if you have a lab, it shouldn't be that big of a problem. And also, if you have time, you can just go ahead and gather these materials, order them as you're building the robot. Whatever parts you're missing, you can just go ahead and order them. Yeah, so we have almost totally ran out of the corner brackets as well. So yeah, this is something we definitely don't just want to throw off. I think we'll have to. Yeah, we'll just see what to do with it after this live stream. We might just disassemble this robot.
Yeah, and we're really rushing this. By the way, we have not been in contact with the software team for about almost 24 hours now. It's we've just been busy building the hardware project, and we initially wanted the software team to take care of the calibration while we were building the hardware, but they're just busy with some meetings. So for now we are just assembling the hardware part. Wood sprinting as fast as we can, so that way everything is ready for them to pick off of, and they can just get started with it right away.
Yeah.
By the way, the wiring becomes really cool when you
Yep, I think there's definitely
it almost just fixes the entire mess of the wiring.
Yeah. I think it's gonna take like a second for us to do that for all of these wires. Yeah. So you really wanna have these sort of connectors attached to all the actuators of the robot, but in our case we didn't had enough for the entire body of the robot, and that's why we are sprinting through this, and a lot of these wires are just bare and it looks messy, but you gotta do what you gotta do to document the entire process. And these, like, just for a disclaimer, these are not good practices to put together a humanoid robot, but you still get a cool looking humanoid robot in the end. It's a win in my book. So we now I'm gonna start attaching this center unit over here, and the goal of this unit is gonna be to hold the robot up while we take really cool videos, pictures, selfies of the robot.
Yeah, we're gonna take a lot of photos of this robot and videos as well.
Oh wow, it's I will have to lay it down like this to put it in place. So let's go with this side and try to align this the right way with the hole on this. Yep, it seems aligned. Ali, can I grab? No worries. I just
Yeah,
found a better alternative.
Um,
Okay, I think this one is locked in. Now let's tighten this on here.
the guide.
Okay, so one done. 3 more connections for this one to go, and they are turning out pretty nicely. For all intensive purposes, I think it's gonna do what I hope it's gonna do. Chat, if you had this robot, what are you gonna train this robot to do? Laundry is like a must, and dishwashing, a lot of the mundane tasks, that's like an obvious, of course. And then Chica dance is also a must. If you don't know, you can look it up, and once you find out what it is, you're also gonna wanna train your robot to do that. I'm gonna grab a few more M4 screws. And yeah, I think I am gonna so it's yeah, let's try with tweezers. I think they are not gonna be, yeah, they're not latching on magnetically to the tweezers, so there's something tweezers are really helpful with. And I'm only gonna attach one of these over here to start off, and then once it's good enough, I'm gonna get the other one in place. Oh, yeah, my head keeps appearing in this live stream. I didn't realize that. Cool. Yep, so I think they are kind of locked in place, and let's just okay, let's do with this one as well, and this part is gonna be sturdy. It's not gonna be going anywhere. Yeah, I think it's stable, I think it's sturdy, and it's gonna hold the robot up for us. Next up, we are gonna bring the other arm and we are gonna attach it here on this assembly, and we're gonna be done. We are gonna be done with the process, and it's so cool and it's so exciting. 11 live streams, 11 days of sprinting, rushing through the project, and we're gonna get to see the upper part of the robot assembled together.
Wow, it's really amazing to see it all coming together.
Yep, this area is a bit tight. We're gonna
Bit
have
too tight, okay.
And especially the position of
There's a lot of play on these screws, so we can unscrew them a little bit.
Done.
If you need.
Okay, so I need a M4 screw over here, and let's get it in there, and then I'm gonna grab the, where the hell is, this one, and I'm gonna loosely locate in place, and then I'm gonna use the good old big forehead screwdriver to tightly locate in its place. But to start off, it has to grab onto that pesky little T-slot in there. Yep, it's not that pesky T-slot, it's running away. We have to grab it first. I think we've got a hold of, guys, I think we've got a hold of it. Let's tighten this one. Okay, let's go. We just have one more to go, and then the upper body, not the upper body, the two arms and the upper frame, the shoulders of the robot is gonna be ready. So we
It's really difficult to see.
almost
in the
through the
image,
process. We're almost done here, guys. And yep, let's.
I think we're gonna hit 50 views today as well. So today was a pretty good day in general.
Yep. And I don't think any of them are like our typical the people that show up every day.
so they-
Sometimes they do leave a comment.
Yeah.
I don't think we've had them.
No comment on 50 views is a new for us.
Yep.
So by 50, there's at least one comment.
Yep. I think today most people are just like dropping in. They're looking at it. They're seeing like it's just a
Yeah.
really boring.
I think because the live streams have been going out for a while now, so the YouTube algorithm is pushing in front of newer audience.
Yeah, most probably. But guys, now we have a handle to pick it up, and
Just
I think
place
we're-
both of these arms. Take it up. Just place both of these arms like this, and it'll hold.
okay. Wow.
Yeah.
Wow,
There we
it
go.
looks so cool. Yeah, dude, it looks so cool in person. And I'm gonna try and move this camera angle a bit just so you guys can see it. So I'm gonna try to move the mic a little bit away. And what's the charging status? Yeah, the charging it looks good. So we can remove it, and let's try and move.
Just take it off. And show it like this for a while, maybe.
Yeah, I think I'm gonna take it off. If you can, just a second. If you can bring the screen up on this bigger display over here, so I can see what I'm exactly showing on the frame. So here's the big reveal. Da-da!
Wow, this looks so cool.
Yep, so... Yep, so this is where we're at after 11 live streams and 11 days of sprinting on this thing. So we have the two arms of the robot ready. For the actual hands of the robot, we don't have the original thing. It's like a replacement sort of part, a very cheap version of it. And yeah, we don't have the actual gripper for the robot yet. We are gonna try and see if we are able to attach that or not. And yeah, I think the next step should be to power this thing up, or I don't know where we're gonna go from here. Some of these connections, if I maybe, yeah, this is what happens when you try to rush through this project. These wires are we got a comment. Reg just said, wow, hello guys. Yeah, welcome to the live stream, Reg. Thank you for coming back to the live streams. And yeah, we, as you can see over here, Reg, we got both the arms of the robot ready, and yeah, this is the right arm, this is Mr. left arm of the robot, and it looks really nice. And Ali, if you can move these limbs a bit, because they look so cool.
Yeah, so I'll try grabbing this upper chest area and try to move the arms if I can over here. So this is like one arm. It's really amazing. And same for this part.
Yep, the motors, they move it really smooth, like it's so fidgety and it's so satisfying, the sound they make while moving. So I hope all the connections and everything in there is going good, because the sound the motors make, it's so satisfying. It's not like something breaking or anything like that. It's a good sort of sound. But yeah, I was saying this about the connections. We were obviously rushing through the entire project, and you need to have these sort of connectors for all the joints of the robot, all the actuators and everything. But a lot of these wires, as you can see over here, they are messy, they are exposed, and if we are to continue this project, if we, let's say, if we make up our mind to try to run software on this, do a few other sprints on this robot, we are gonna be doing what do you call it, like hard soldering with all the connections. We're gonna be joining them permanently for now, and then we're simply gonna be cutting them and exposing the copper traces later on. I thought you start with the legs, but it's a very good start. I can't wait to see it working. Yep, same here, Reg. Same here.
Yeah.
I honestly didn't know where we started from, but we just kind of thought of starting with the arms.
Yeah.
And that's, but Reg, if you can see how tiny it is in practice, it feels really
but
huge.
It's really small.
Yeah, it feels really big, but if you can see compared to my hand over here, or maybe I don't know, man, compared to like this Ghibli probe over here. Shout out to My Neighbor Totoro, one of the good Studio Ghibli movies. Yeah, it looks really small in comparison to other things. So it
In comparison with a water bottle.
Yeah, this is a Mizu water bottle, and yep, this is the size of the robot, and it's really tiny. But
Yeah, it's a light version, humanoid light. But it looks really good in person. So the camera really does not do it justice. Once we have the arm assembled, it's really beautiful and it's really cool to play with it and make motions. It makes really amazing sounds once it rotates and moves.
Yep. So I'm really looking forward to if we can do a sprint on uploading software to only the arms of the robot and maybe try to get it working. I would really love to do that. If we have something like that planned, I will upload a post on my YouTube page before doing a live stream. But yeah, it would even if we like upload a software to just move the hands up and down and maybe make it wave or something like that, it's gonna look really cool. Regarding the update on the remaining body of the robot, I am not exactly sure when we are gonna be proceeding with that. Will provide an update on that maybe 1 to 2 days on our YouTube post. But moving back to, it's probably Reg who left a like on the video. Thank you so much for that, Reg. You're the only one who is supporting these live streams, by the way. Thank you so much for that. And regarding the rest of the robot's body, we you're gonna be able to see a bit about around the lab over here. So yeah, this is the what the lab looks like over the side. So yeah, we had a lot of tools already stored up over there from our previous projects, and that's why we were able to sprint through this. Otherwise, if we were just ordering and waiting for the bill of materials, we probably wouldn't be able to put it together in like 10 or 11 days only. And for the remaining actuators, for the actuators of the legs, as you can see, everything is ready. They are just not calibrated yet, and I have to do slight work on them. The most boring part of this work is changing these wires from 20 gauge back to 24 gauge, because in the very first live stream when we were rushing through this, we didn't had 24 gauge wire, so I soldered 20 gauge wire on that. But the connections are really messy, and I really want to fix them before putting everything together on the leg side of the project. But we have the actuators mostly ready over here, and we just have to calibrate them using the PC down over there. So that's the PC. And regarding the parts, 3D printed parts for the legs of the robot, we have all stored over here as well. So yeah, we have the parts for building the legs of the robot ready as well over here. So we can sprint through this. We can maybe do a couple of more live streams to put together the entire body of the robot, and it's gonna look really cool. I really want to do it. But yeah, whether we do or those live streams or not, like in the upcoming days, we're gonna have to see. Yeah, we're gonna have to get in touch with the software team, see the timeline and the milestones, and decide based off on that. Yep. So that's the progress so far. That's all she said, and I'm gonna attach this back over here to our default position. It's and I'm gonna remove this Studio Ghibli bus stop sign from here. It's one of my best purchases for sure. And the motion in all of these, it looks really smooth. Like I don't know if you're able to hear it or not, but it makes really satisfying sound when you move them around. And it's also like really smooth. It's not struggling or anything. So I hope if we push software in these arms, they come alive and they move in whatever way we want them to move. Yeah, and once again, it's really beautiful to look at in real life. The assembled product looks pretty good in the end. Yep. Yeah, I think we can call it a day over
Yeah, that was pretty much what we were sprinting for today. Our goal was to have both the arms attached with the chest area of the aluminum profiles, and that's done. It seems to be pretty smooth, working fine. So yeah, we can at this point we're just gonna call it a day. We'll send the update to the software team, and yeah, we'll make the next plan of action with them.
Yep, and for a small update on the playlist I'm making for putting this robot together, so we obviously are gonna have these live streams live on the channel for anyone to watch, but they're really long. I'm making a summarized version of all the steps and the process of building this robot, the process of putting everything together. And today I recorded a video which is gonna be going live later in the day, which is basically about soldering these connections. They are pretty small, and I mentioned in the live streams how I use solder flux to kind of join them together, so making sure we don't have any short circuit or anything like that, and also where to attach the motor winding cables, the A, B and C for the BLDC motor, and also the power cable connections which go over here. So I have made a really brief summarized version of that process, and I'm gonna be uploading that video later today. And probably today I'm gonna be making a playlist, and I'm gonna add all the videos regarding the assembly and the process so far as short summarized versions of those videos in that playlist. So yeah, it's gonna be up live on our channel.
Awesome. We're gonna call it a day at this point.
Yep, 50 views solid.
Yeah,
And
today was a pretty good day. It was a pretty chill day, and we were able to put together all of the actuators relatively easily in only 3 hours. Didn't even take like 4 or 5 hours as we push with our other live streams, and yeah, pretty good progress today.
yeah, Reg just said nice work. Thank you so much, Reg, and thank you for always supporting these live streams. Thank you for being interested in this stuff. A lot of people are not interested in this kind of stuff. Earlier in the live stream, I was also mentioning we do have a lot of entertaining robotics related projects lined up that we're gonna be uploading on our channel, and these tutorials and these videos and cool projects like this humanoids, maybe the MIT Cheetah and open source version of that. These kinds of educational videos are always going to be coming on our channel, but we do have a lot of entertaining videos planned as well to hopefully bring more attention to this. And if children, kids or any other people that came in for education, if they want to, for entertainment, sorry, if they are interested in learning about this process, these tutorials are going to be up there for them. So that's kind of the path we're taking with the channel. And right now it's pretty boring, so thank you so much for supporting the channel, being interested in the videos we're making. But I'm gonna be pushing out a lot more entertaining stuff as well on the channel, and these tutorials are always gonna be happening on the channel. So yeah, once again thank you for supporting everything. Yep, so yeah, I'm gonna upload the soldering tutorial later in the day today, and I'm gonna be making a playlist. And regarding the future of this, like when we are gonna be proceeding with this robot, I'm gonna provide an update on that in the post section of my channel. Maybe I'll make a GIF or a video as well of this robot, just kind of some better pictures and videos of this robot, and maybe we'll upload that over there as well. Thank you so much everyone for tuning in. Thank you so much for supporting and viewing these videos. And yeah, until next time, take care everyone.
Yeah. Have a good one, everyone.
Cheers.
Bye bye.
Bye bye. Bye.